Hello and welcome back. In section 12.2, we get to work with arithmetic sequences. So the key feature of an arithmetic sequence, the difference between terms, specifically consecutive terms, some fixed constant. So in other words, a sub n minus a sub n minus 1 is worth some d. D is referred to as the common difference. And a sub 1 we just call some arbitrary a. So first we're going to just check and see if a couple of sequences fit this description. So sequence b sub n, we're going to make it by doing 7 times n minus 2. I don't know, is that arithmetic? So our generic term, b sub n, b sub n minus 2, b sub n minus 1 would be 7 times, instead of n minus 1. We have a minus 2 there. So b sub n minus b sub n minus 1, so the difference in consecutive terms, we want it to be some fixed common difference. So 7n minus 2 minus the quantity, we'll do a little distributing here, 7n minus 7 minus 2. Minus a negative 7 is 7. That is a fixed constant, so this is arithmetic. This is a yes. However, if we tried maybe c sub n is n squared plus 4. C sub n squared plus 4, c sub n plus n minus 1, my apologies there, c sub n minus 1, we could do it that way, we would just have to put the n plus 1 first. C sub n minus 1 though, n minus 1 quantity squared plus 4. So c sub n minus c sub n minus 1, n squared plus 4, minus the quantity n squared minus 2n plus 1 plus 4. So c sub n minus c sub n minus 1, though, is a variable quantity 2n minus 1. Because of the variable quantity, in other words, the difference changes based on the value of n, this is not arithmetic. So now that we know what is and is not arithmetic, we can look at terms. A sub 1 we just call our a. A sub 2 would be a sub 1 plus whatever the common difference is. A sub 3 would be a sub 2 plus whatever the common difference is, and so on. But we can work our way kind of back down the line here. A sub 2, we have either by itself or we have defined with respect to a sub 1 again. So by substitution, I can replace a sub 2 with a sub 1 plus d. So that's replacing just this part, and we have another d, so a sub 1 plus 2d. Similarly, a sub 4, we can replace the a sub 3 with a sub 1 plus 2d, and add another d, so a sub 1 plus 3d, and so, so on. And in general, our a sub nth term would be then a sub 1 plus, notice here the number of common differences we use is 1 less than the index. So n minus 1 d. So for example, if we had, let's see, 5, 9, 13, 17, 21, and we wanted to find the 209th term. So we don't want to sit here and label out 209 total values. We want to sort of use this idea that we figured out. So a sub 209 is going to be a sub 1, so 5, plus 208, so 1 less than the index, times the common difference. Common difference here, you'll notice, is 4, and it's going up by 4 each time, so a positive 4. So a sub 209 is worth 837. Let's see. Now, more room for the next one. We'll just flip it. So these next ones just sort of get us to learn a little bit more about how these things work by kind of turning it into fun little puzzles. So let's say we're told that the 12th term of the sequence is 50. The 20th term is negative 14. And we'll do a few things with this. So first we'll find the common difference. So this one, we could really just kind of set up a nice, pretty little system here. So a sub 1 plus 11 times the common difference is 50. So that is for a sub 12. A sub 20 is a sub 1 plus 19 times the common difference, and that spit out a negative 14. So to find our common difference, we just sort of treat this as if this were a system of equations, and we can use just elimination method would be pretty quick on this guy. So negative 8 times our common difference is worth 64, so our common difference here is a negative 8. So we're dropping by 8 each time. So the sign does matter. And that does fit with what you saw. The 12th term was at a positive number. The 20th term, we were down to a negative number. And they're always changing by the same amount, so that had to be decreasing each time. All right, so now we can, that's one of the things we can do. We can also find a sub 1. Find out what our first term is. Well, by a little substitution of what we know, a sub 1 plus 11 times d is worth 50, but we know d is negative 8, so a sub 1 minus 88 is 50. So a sub 1 is 138. So our first term was 138. So then we can find the nth term. Well, continue working up here. A sub n, if you'll recall, is a sub 1 plus n minus 1 times our common difference. We know the first term. We just figured that part out. We know the common difference. So we have enough to write our generic nth term. So our first term, 138, plus n minus 1 times our common difference. Common difference, though, was a negative 8. So then we just do a little bit of clean up, a little simplifying. Negative 8n, and that would be plus 138 plus 8. So a sub n, negative 8 times n plus 146. So that's our nth term. And if we wanted to describe the sequence even, this would be just sequence a sub n is, and it would follow the formula for that term that we just figured out. So just based on knowing 2 bits of information, 12th term was 50, 20th term was negative 14, we could figure out the whole thing. Now another fun little tool, a little thing we can do with these, we can find the sum of an arithmetic sequence. That's a sad little C there. Well, our sum of the first n terms, so this is what this little subscript is telling you, sum of the first n terms. First term plus second term plus third term plus nth term. We can do a little substitution on that, though. Recall that, for example, a sub 2 was a sub 1 plus d, and a sub 3 was a sub 1 plus 2d, and our nth term would be a sub 1 plus 1 less than the index times d. Each one of these is going to have an a sub 1, and see if you can figure out how many of those we should have. Okay, this was for our nth term, so we should have n of them since we started at 1. So we would have n times a sub 1. Then we have plus d plus 2d plus 3d plus all the way to n minus 1 times d. With that part, this much of it, we can do a little factoring. We can pull a common factor of d, leaving us 1 plus 2 plus 3 all the way to n minus 1. This should look familiar. This should look like what we did in section 12.1, except instead of the sum of the first n terms, this is the sum of the first n minus 1 terms. But the idea is the same. Sum of the first n terms was n by n plus 1 over 2. This is going to be n minus 1 by n over 2. So this is one way we can find the sum of an arithmetic sequence if we know the first term, common difference, and how many terms you want. We can do a little bit of work with that and rearrange it to a simpler looking formula where we would just have to know, it turns out, the first and last, as well as how many terms we want. So a little bit of manipulation on this is coming. So I'm going to call this 2n(a1) over 2. So this one, notice I've just multiplied by 1. I multiplied the top and the bottom by 2. You'll see why in a moment. Plus, let me go ahead and rearrange this and call this n over 2 times d times n minus 1. So now notice n over 2 is attached to both of these fellows. Let's factor that. So now I have two a sub 1s, or just a sub 1 plus a sub 1, plus d times n minus 1. This much of it, though, what does that look like? That should look like a sub n to you. First term plus n minus 1 additions of d. That's our nth term. So if we know the first, last, and how many terms, we can do n over 2 by a sub 1 plus a sub n. So that one we know the first, last, and number of terms. All right, so let's put that to work for us. So we'll take a look at sequence that we have 4, 9, 14, 19, and so on. And we're going to do this two different ways. So the first time we go through it, we're going to say, okay, we're going to stop when we hit 104. So for this one, we have our first term and our last term. We don't know the number of terms. Well, we do know what the last term looks like, though. So a sub n is a sub 1 plus n minus 1 times the common difference. So plug in what we know. 104 is our nth term. A sub 1 was 4. We don't know what n is, so we also don't know what n minus 1 is. Our common difference, though, we can see is 5. So now we have 100 is worth n minus 1 by 5. So 20 is n minus 1, so n is 21. So there are 21 terms. So now we have enough for our sum. So S sub 21 is what we're looking for, is 21 over 2 times a sub 1 plus a sub n. S sub 21, 21 halves by 108. So half of 108 is 54, so 21 by 54. And then it's just plug and chug. So 1,134. So now we're going to examine the same problem, only this time, let's say for the sake of argument, we didn't know that the top number was going to be 104, but they told us find the sum of the first 21 terms. Well, we would have 21 of these 4s if we wrote them out the long way. So each of the terms was a sub 1 plus something else. Our common difference was 5. And then we had 1 of those, plus 2 of those, plus 3 of those, all the way to n minus 1 of those. N here, though, is 21. So S sub 21, 84, plus 5 times 20, n minus 1, times n 21 over 2. So S sub 21, 84 plus 5 by 210. So S sub 21, 84 plus 1050. So S sub 21, 5, 13, 1, 10, and 1, 11, 1,134. Turns out the same either way. So we'll get the same sum either way. So either figure out what the last term is or just use your formula from 12.1. Either way, fun little way to find sum of a large number of terms of an arithmetic sequence. So in 12.2, those of you trying the book problems, 7 to 55 on the odds, and number 63 is a fun problem as well. I'll try to find an equivalent one for the My Math Lab fans out there. If you have any questions, please get in touch with me. Otherwise, I'll see you next time. Stay safe out there.